Let's look at mapping your internal network so you can see what devices are on it, their IP addresses, what ports and services they are running. The IP address of the device you are using now will be assigned an IP address either by DHCP, which is Dynamic Host Configuration Protocol, or it will be statically assigned. If it's statically assigned, that'll probably be by you or whoever runs your internal network. And when clients are set to use DHCP, a DHCP server will dish out an IP address for that device to use, and usually in probably 99% of cases on a local network, that's going to be your router. Let's look at how you can determine whether or not you're using DHCP. You know how to determine your IP address in Windows, OS X and Linux. We're in Windows here now, so let's type ipconfig/all, and then I pipe that into more just to slow it down. But the command you need is ipconfig/all. And then if we look here, we can see DHCP enabled, no, and that's for this device here. DHCP is not enabled. If I go down again, I can see I've got another network interface here, and DHCP is enabled. So that's how you determine it in Windows. On Linux, it will very much depend on your distribution, but this is Kali or Debian, and you can do it with this command here, just catting the syslog for DHCP, and you can see the request for DHCP from the DHCP client, and it even tells us who is the DHCP server, which is 192.168.1, or you can do it through the network manager through here. And there you go, it says automatic DHCP. And on Mac, if you go to System Preferences, go to Network, choose the network adapter, whether it's Wi-Fi or Ethernet, then go to Advanced, and you'll be able to see they're using DHCP. If your IP addresses are not dynamically assigned with DHCP, then they have been statically assigned. So let's map the local network to see what devices we've got on there. We can use Kali to do that, and we can use a couple of tools in Kali if we want. So Nmap, and then there's also Zenmap. Zenmap is the GUI for Nmap, so we can use either of those. If you're using a VM to run Kali, then make sure the network card is in bridge mode. Nmap is really the go-to port scanner for most situations. In fact, it's a port scanner with quite a few other features as well. Nmap and Zenmap is available for Mac OS X and Windows 2, and you can get them from here, just download them from here, or with Windows you can download them with Choco, or with Mac you can download it with Brew. So we need to determine what our local network is so we can look at what our subnet mask and IP address is. So here I can see my IP address is 192.168.1.40 with a subnet mask of 24. If you're not sure what subnet masks are, then that's something you need to look into. But that means that this is the network and these are the devices. So from 192.168.1.1 to 192.168.1.255 are possible devices for this network or this subnet. So 255 possible devices. So let's scan the local network. Your network is likely to be very similar, 192.168.1 something. So you would put in whatever your subnet mask is and a 0 instead of your device IP for the final number. And T is for fast execution and F is for few ports. So it's found 5 hosts and it's found ports on all of them. .40, .38, .35, .8, .1. Let's do this in ZenMap now. Just type ZenMap, run as root. I can also do it like this as well, in this format, so I can say 1 to 254 instead of putting the /24 as a subnet mask on. If I do it in this, it's going to give us a graphical view of the network, which is quite nice. And the A, by the way, is for OS detection, version detection, script scanning, and trace route, and the V is for verbose. So let's scan. This can take a little time because we're doing a verbose and we're also doing full detection. And there it's finished. So let's make it a little bit bigger. You can see what's going on. So the results here, these are the same results you would get if you were doing it via the command line, but also you get it to store the information via the GUI here. As we can see, it's found a Linux router. It's also found some other device, it's not quite sure what it is. A HP router, which is actually probably a printer. Another device here, and this device here. And we can look at the topology view. And you can see what's on your network. So pretty cool. And for each of them, we can look at the ports that are open. So you can see here 22, 53, 80. Lots of ports open on that one. And it gives in a way what it is. HP printer. Nothing on that one. Nothing on the Kali Linux. You've also got host details. See a bit more on these. Or you can do it via services. We can see this is running Dropbear SSHD. It's giving away its version information. So that's Nmap and ZenMap, enabling you to map your network and see what's on it. For Windows, other than ZenMap and Nmap, there's also Superscanner version 3, which I recommend. There's actually lots of port scanners, it's just I'm letting you know of the ones I recommend, and that's Nmap, ZenMap, and for Windows Superscan as well. For mobile, I recommend Fing, which is free and it's really excellent. It's for both iOS and Android. This is the Android version here. So it scans and finds the resulting devices. And that's what it looks like. Same sort of output as you get with Nmap. And here's the version for iOS, which you can download from here. For some reason, Apple's actually having a problem with their site at the moment, but that looks like this. And yeah, that's really good as well. If your mobile's on the network, just start the scan, same as you did with Nmap, or same as I showed you with Nmap, and it'll show you all the devices, all the ports, all the services. Just like that. So that's port scanning the network and mapping the network. Now we're going to look at vulnerability scanning on your internal network to see whether any of your devices have got known vulnerabilities. Here, this is where you can download Microsoft's free Baseline Security Analyzer, which is MBSA, Microsoft Baseline Security Analyzer. And this is what it looks like here. You can run this against Windows machines. Just download it, install it, and run it. So you simply click on Scan a Computer, or you can scan multiple computers at the same time. It's pretty intuitive. And you put in the IP address here, 192.168. What have you. Then start the scan. Pretty simple. and you get something like this, which will report on any issues that you've got. So it's telling me there's a problem with the Windows firewall, that some user accounts, 3 or 4 have blank passwords, the automatic updates feature has not been configured, etc. So it's a fairly basic test or vulnerability scan, but to be honest, if you've got any problems on this, then it's not good. For example, if you've got your auto updates not working, then that's something that's basic security. So that's Microsoft's Baseline Security Analyzer for Windows only. Kali has the Open VAS vulnerability scanner, which is free, which you can find if you go here, vulnerability analysis, and you can see these 3 options here. If it's the first time that you have run it, then you need to run this initial setup, follow the prompts, set it up for it to start working. You shouldn't have any problems. It tends to work fine. If you do have problems, then do a search to see what that problem might be, but generally it should be fine because you're using a standard build, and then just start the service. So that's starting. It can take a little bit to start, and there we can see it's running on the local host, and you can see it says Open VAS D, and also here. So you want to go to this address here, 127.0.0.1 on port 9392, which is what it's running on. You're going to have to accept the certificate because it's a self-signed certificate, obviously. You can change that if you want to. And then you need to enter the username and password. You can set this up. And if you see this command here, this will create a user called admin2 and put it in the admin group. So that's created the user. And if you enter this command here, you can change the password for the account. And see, I've changed that to admin as the password. The quickest way to get a scan going with this one is to go to this icon here, which I guess is supposed to be a wizard's wand, and go to Advanced Task Wizard. And from here, you can enter the host that you want to scan. So maybe you want to scan your whole network, like so, or maybe you just want to scan an individual host, and you can choose the scan config type depending on what it is you're trying to do. You can just do some host discovery and system discovery, or you can do a full-on vulnerability scan and test. The deeper it is, the more tests, the longer it takes. So it's really up to you what you run. But for a complete test, it should be this. And once you have scanned it, if you go here and to reports, you'll see the report on the scan that you've done. And I've done a scan here on 192.168.1.50. And if you look here, you'll see a lot of vulnerabilities. This was actually run against Metasploitable, which is a deliberately vulnerable virtual machine, which is available from here. If you want to try it yourself, you download it, set it up as a virtual machine, and then scan it if you want to practice scanning and attacking boxes. Back to OpenVAS. So yeah, so it shows you all of the vulnerabilities. You can see what ports it's on. So we can see here we've got a SSH brute force login with default credentials, and it's able to log in using user as the user and password as the password. And there you go. And it'll also often have how to resolve it. So here you've got the solution for how to resolve it, and it has links to the CVEs so you can find out more details about it. So yeah, you can find out whether you have any potential vulnerabilities. If you've got your devices up to date, you should be reasonably good. Your Internet of Things devices like your smart TV or your router potentially may have problems. But like I say, those that are updated should be okay of your regular devices. It's more of your Internet of Things that may be vulnerable. And this is the OpenVAS website where you can find further information on it. It does actually have an OpenVAS appliance, but unfortunately it's in German. If you speak German, then that might be useful to you. So that's OpenVAS. This is Nessus Home. This allows you to scan your personal home network, or at least up to 16 IP addresses per scanner. A full version used to be free for non-commercial use, but that's not the case anymore, I'm afraid. But you can still get this home edition for your internal IP addresses. OpenVAS actually is based on an older version of Nessus. Nessus is very good. It's probably the leading vulnerability scanner. So it's highly recommended. You obviously need to register and fill in your details to get your home edition. And it's got quite an intuitive, easy to use interface. And that's what it looks like if you're curious. It's available for Windows, Linux and Mac OS X. And there is a paid version, but as you can see it's quite expensive and really only for people who are professional pen testers. So that's Nessus. There's also the Qualys FreeScan, the online vulnerability scanner, which we already discussed. You can scan the network internally with that as well. Haven't tested that, but you can do it. With vulnerability scanners, you have the choice of doing unauthenticated or authenticated scans, and this makes a big difference. With an unauthenticated scan, the scanner acts much like the same as a hacker might, in that they have no access to the device and are trying to look for vulnerabilities on the running services. With an authenticated scan, it does the same as the unauthenticated scan plus more. You provide login details, such as I have here with the SSH username Bob and password. The scanner then logs into the device and also runs scripts and vulnerability checks for internal vulnerabilities. And it will also be able to enumerate things like your patch level. It emulates what an attacker might be looking for once he has access onto a device. An authenticated scan is more conclusive, often much more conclusive. On the downside, if you give a vulnerability scanner root or admin access, it could mess up the config of your device with some unknown check it is performing. It shouldn't, but the risk is there. Nessus and Qualys are mature commercial products, but OpenVAS is not, but it is free. So bear that in mind. And one other thing, when it comes to SSH, you often want to disable for security the SSHing into a box as root. So usually you SSH to a box as a standard user and use sudo to run commands, or you su to root. So if you're using a vulnerability scanner, you have to be able to perhaps log in as a standard user and then switch to a root user. OpenVAS does not have that functionality. Nessus, for example, does. So that's vulnerability scanners. You've got free trials, you've got commercial versions, plenty to be having a look at. And if you want to try it out on other than your machines, then you can use Metasploitable, which is here, which I showed you before.